put this on record then. So if we go ahead and look at what I have posted for question 19, then this question and question 20 are clearly different from the other questions on the assignment dealing with the consumer choice problem. So we have to kind of do a little bit of illustration to sort of talk about what's going on. And I am not going to spend a ton of time on these two questions, even though they're really important, because there's a lot of stuff that's already been posted on YouTube about this. So you know, you need to go there and watch those videos in detail. But let's go ahead and talk about this just a little bit as we get the setup. Okay. Let's see. Okay. Greg got us. Are you here this morning?
Yep.
Okay. How you doing, Greg?
Pretty good.
Pretty good. And let's also talk to Stephen Schlosser. Hi, Stephen. How you doing? Maybe. What about Russell? I see you above Stephen. Oh.
Yeah.
Okay. Who responded? Yeah.
Russell.
Okay, Russell. How's it going this morning?
Fine. Cold.
Oh yeah, it's a little bit
Freezing.
cold. Okay. Okay. Well, wrap a blanket around your shoulders. You're probably at home, I'm guessing. But anyway, so let's go ahead and read through this question together, and you know, then we can talk about it. So we've got Greg and we've got Russell. So notice that for this type of a question, and maybe I'll, you know, just change the formatting a little bit to kind of emphasize this stuff. Just like drag it out a little bit, if I can. Make it a little bit easier to read. And okay. All right. So the important thing is that notice this last part, and maybe I can go ahead and grab it and highlight it. So Greg and Russell, as you read through this question, the prompt is just like the other questions, right? You agree? It doesn't seem that mysterious at the beginning.
Yeah.
Yeah.
Okay. Now I'm doing this, if I can, but now we get down to the actual, what some people refer to as the call to the question, which is kind of like, okay, we have the setup part, But now what are we actually being asked to do? And I'll put it in red, right? And the particular part of this, and I wish I could just highlight certain sections, but it doesn't let me do that. That's why I pulled this off. So at least I could, take the call to the question part and I could color it differently. It says, what or how many tacos would be consumed by your professor at the new prices? So when we look at this, so I'll say, Russell, what are the old prices?
Old prices would be 7 for tacos and 2 for tequila.
Right. Yeah. And Greg, then what are the new prices?
So the new prices of tacos changed to 6, and we don't know what tequila changes to.
Well, yeah, but tequila isn't changed, right?
So 2.
Yeah. So and you should know that probably like from the other setup questions. But anyway, yeah. So we have 2 sets of prices. We have the old prices, which are 7 and 2, and then we have the new prices, which are 6 and 2. And yeah, I should point out, and maybe you remember a little bit last time, Greg, when we kind of talked about the point of, or at least one of the main points of this assignment. I won't say the only point. There are actually 2 main points to this assignment, or maybe 3. And the main point was for us to be able to see the connection between the consumer choice problem and demand. Do you remember we talked about that?
Yeah, I actually wasn't able to make that lecture.
Well, what did you watch the video afterward?
No, I haven't been able to yet.
Well, do because you're gonna fall behind because we're gonna move on to the next thing, and it should be a top priority.
Sounds good.
Well, I mean, it's yeah, do. But yeah, so the first part of this assignment is so that we understand that there's a price expansion path that we can construct with the consumer choice problem, and that price expansion path has this information we need to construct the demand curve for the consumer. That's like point number 1. And or I like the main point number 1. And then here we're starting to get to this second point, which is okay, what really happens to the consumer when the price of one of the goods changes? Well, one of the things is we can use that price change again to construct the price expansion path. You could see here that the price of tacos is $7. We'll get out of our consumer choice problem a quantity of tacos that the consumer would purchase from those first sets of prices. And then for the second set of prices, you'll have a lower price of tacos. You just change the price of one of the goods. And that's what happens when we construct demand. And it's probably not really obvious. But maybe I'll ask you, Russell. So when we've talked about demand in the past in your other classes, has anybody ever said to you this particular phrase? Do you remember it? It's do you remember that?
I think I've seen that in my intro to micro. So it's been like a year and a half since I actually know what it meant. But that does seem familiar.
Yeah. So this little phrase is a Latin phrase, and I don't know Latin, and nobody really does because it's a dead language. But I'm told by people that it's pronounced caterus paribus. And that's the way I normally hear people say it. But it means other things equal.
Yeah, that's familiar.
Okay. And this is sort of a scientific methodology that, so the scientific method, and we talked a little bit about that at the very beginning of the semester. But the whole idea is, when we change the price of tacos and we construct the demand curve for tacos, then the demand curve that we are constructing is supposed to be constructed holding all of the things that can influence demand for tacos constant. And the idea is then to isolate the effect of just changing the price of one of the goods and seeing how that influences the consumer's demand response, how it influences the consumer's behavior. Does that make sense, Russell?
Yeah, I think so.
Yeah, and why might you want to do that? You have an idea?
Off the top of my head, no.
No. Okay, well, imagine this, right? So imagine that other things that we're changing simultaneously that influence the demand behavior. Okay, we're changing the price of tacos, but we're also changing the consumer's budget, and we're also changing the price of other goods that are complements or substitutes, right? Well, when we see a new amount of tacos consumed, if we're changing a bunch of things at the same time, how do we know what is the impact of the price of tacos, right? It's like, I mean, I don't know if I can give you another real world example of things changing simultaneously where you can't really identify the effect. But I'm sure that you do this all the time, right? So at least in your common sense thinking about stuff. So Russell, are you an early riser? Are you somebody that's good at getting up in the morning, or is that kind of a?
It kind of depends, but I typically can be, yes.
Yeah, so it depends, right?
Yeah.
What does it depend on?
Mostly depends on if my dog decides to be up at 3 a.m.
Okay.
Other than that, yeah, I can get it pretty easy.
So based on your experience, right? Is it ever hard for you to wake up early in the morning?
Sometimes that would probably depend on like if I have something I don't want to do that day and I just don't want to get out of bed.
Okay. So have you ever stayed up really late and gotten very little sleep, or maybe been sick and had something that you didn't want to do in the morning all going on at the same time?
Yeah,
Okay.
I've had that happen.
Okay. So how do you know which one of those influences, if you had them all three at the same time, right? Suppose you've always gotten up at 5 o'clock in the morning every morning, right? Your dog always gets up, you get up, you go to bed at the same time. And then suddenly one day, out of the blue, you stay up late partying, you don't get much sleep, and um, you're sick, and you don't want to have something, and you have something you don't want to, and your dog doesn't get up, right? If that's the first time that's ever happened to you, right, you would have a hard time teasing out, well, which one of the things was it this morning that made
Yeah.
it difficult for me to get up? So anyway, the way that we take care of that in doing any sort of analysis is we just change one thing at a time. So in this example, right, you'd say, well, gosh, I don't know what was the impact of me staying up late and partying the night before and me getting up in the morning. So let's only do that and see how it influences me. Maybe I get up a half hour later. That was the impact of just that. And then the next day, right, you'll do something, different. You'll say, okay, what I'm going to do is I'm going to take my dog and put my dog over at my friend's house. And I'm going to see what's the impact of just the dog, right? And that way you can tease out the cause and effect relationships and the impacts of each of the individual things that can influence your, in this case, effect, which is what time you want to get up in the morning. So we know that demand is influenced by income, price of goods, the consumer's preferences as represented by our alpha parameter, and the prices of substitutes and complements. And so anyway, if you should probably remember the some of those things from principles and the stuff we talked about earlier in terms of what can shift demand and supply, that there are multiple things that can affect demand. So here, when we're talking about demand, our experiment is to just change the price of the goods price itself, what you would often call the goods in economics, the goods own price. Okay, so we're just changing the price of tacos, and we're letting all other prices and the consumer's budget and other things be constant. That's how we construct the price expansion path. That's how we construct the demand curve. So we have this isolated cause and effect relationship. And so that's the first part of this problem. And now we're doing something different, right? We're saying, oh, okay, we want to have utility be held constant instead. You see the second part, Greg, where it says, so now we're asking at the new prices, and we're holding utility constant at the original consumption bundle level of utility. So this is different, right? So here we are, and let me see if I pull this out. A little bit. Here, we're asking a different question, namely, what happens when the consumer faces the new prices, and I'll say old because I just mean by original level of utility. So Greg, can you see that this is kind of a different question, right?
Yeah.
Yeah. So, and we're gonna call the consumer's choice of how much X to consume at, and I'm gonna put new prices and old utility. XS. Okay. So we're finding something that we haven't found before. And again, we can talk about it a little bit here in the live lecture portion, but it's something that's discussed in great deal in the recorded lectures. So you know, please go and watch those carefully. Otherwise, you may end up not really understanding, you know, what's the point of this whole exercise. It's one of those things that is, you know, the result of people getting Nobel Prizes and it taking, you know, a long time to kind of absorb, you know, why this is going on. But the purpose of this, you know, question is, the reason why we're asking it is because we want to understand why it is that some demand curves do slope upward. And ultimately, we're refining the theory of consumer choice, of rational consumer behavior, to be able to include special cases where demand curves do slope upward. And just to kind of give you guys a teaser, and we talked about this last time, but rational consumers, when they're in particular situations, right? So it's not, you know, irrational behavior, but in particular types of situations, they do sometimes respond to an increase in price by purchasing more of a good. And it's important, you know, I don't know. So Greg, can you think of any cases off the top of your head that are kind of real world, where if the price of something increases, you would want to buy more of it?
I mean, the only thing that I can think of, and it doesn't really relate to me, but it's like how a lot of clothes have like a scarce supply, so they have high prices, and that kind of creates, like, people want it more because it's scarce and it's like has a brand name behind it. That's just what came first to mind.
Yeah, so we talked about that sort of thing a little bit last time, but you know, it's interesting because you know, those are kind of like status symbol, you know, examples, and you know, it's kind of interesting, right? Because you know, if you're into buying Gucci or something like that, then I kind of bet that if you're trying to buy it because it's exclusive and you think other people are gonna you know, like you better because you wear a particular brand of clothing or something like that, then other things being equal, you would probably like to get it for less money if you could. But anyway, that's a special example, but that's not the sort of thing that you would expect to happen with regular goods like toilet paper and shampoo and gasoline, right?
Yeah.
But can you, in the context of things that would normally be purchased, can you think of any examples where if the price was higher, you'd want to purchase more?
Not really, no.
No, yeah, it's kind of hard. And what about you, Russell? Do you have any ideas?
Top of my head, no. Sorry.
No, yeah, no, that's fine. It's fine because it's difficult. Well, the two things that people normally bring up, and we already talked about this, are, these kind of status goods, and so we'll put them aside because again, we're gonna explain this in the context of just regular goods and normal sort of consumer behavior. So we'll rule out status goods. The other one that people sometimes mention, which is not really a good, are assets, right? So we also want to push those to one side. So sometimes people, when I ask this question, they say, oh, well, like, what about Bitcoin? Or what about, Google stock or Tesla stock, right? When the price goes up, maybe I want more of it because I think, that's a signal or something that the price is going to be going up in the future. But I want to distinguish asset prices, and we do talk about asset prices in economics, and there's a lot in money and banking and finance and stuff like that. But in your mind, the majority of the theory that we're talking about here doesn't have a very definite correspondence to, even though rational consumers do purchase assets. Notice that they're purchasing the assets not because they want to consume them, right, directly, in the same way that they don't consume money here. It's just part of their budget to spend on other goods, right? But assets are purchased as a way of providing budget for future consumption goods. Do you see what I mean, Russell?
Yeah, I think so.
Yeah, so you would buy Bitcoin because maybe you want it part of your asset portfolio, so that when you retire, you can sell it, and then you're going to get money so that you can purchase clothes and shoes and cars and things like that, right? Stuff you actually consume. Right, your 401k type stuff. So assets aren't consumption goods. So put those to one side, and then think about this question. When would it be the case that if the price of a good increases a regular good, you might want to consume more? And we only really know, and this theory only explains one case, which we talked about a little bit last time, which are what we call Giffen goods. And remember, the way to think about a Giffen good is to say that it's a super inferior good. And so the best way to think about Giffen goods and why you get upward sloping demand curves under certain conditions with Giffen goods, and that's what we're teasing out here, is when does it happen, is there's something really strange that happens in certain situations. And so this is probably so Russell and Greg, do you guys live with your parents, or do you live separately? Do you rent or own your own home?
I rent at my mom's house.
Oh, so you do, your mom does charge you rent. Does she charge you market rate, or do you get a good
I
deal?
get a deal. I get a pretty good.
Okay. Yeah, okay. So the reason why I bring it up is because that's probably the easiest way to think about it. Everybody knows that rent is expensive in Southern California. And because of that, in California, particularly, where we live, closer to the coast and things like that, people tend to spend a large percentage of their income. So, Russell, have you ever thought about moving out of your mom's house?
Nope.
No, just stay at home indefinitely, right? Okay. Well, and probably because it would be expensive, right? So,
Yeah.
does anybody here, if anybody else wants to play along, does anybody here rent their own apartment or their own house or anything like that? Nobody. Okay. So, okay, Russell, let's go ahead and continue with you for just a minute. Um, so, if you were to, rent your own um, place, how much do you think your rent would be per month for, someplace that you'd be okay living in?
In California,
Yeah.
uh, probably like 650 to 850 would probably be what was expected.
Okay. And you mean, so for a one bedroom apartment, or you mean like sharing with somebody?
Yeah, I'm just saying like one bedroom apartment. Otherwise, I mean, if I could help it, I'd probably just end up having a roommate or something.
Yeah. Well,
Maybe.
so I'll tell you, you'd have to kind of like, look around for apartments. But I bet you, for most of the places that you would want to live, you'd find out that the rent was even more than that. I think
Oh, great.
you'd probably be lucky to find a decent apartment for less than about one bedroom apartment in some place you'd want to live for less than about $1,500 a month. But you could get a one for 850. It's possible, but you might, I don't know if it'd be a great fit for you if you're super comfortable there.
Mhm.
Go look around and then give your mom a hug. Right? but but the point is that would be a big share of your income. So now imagine that the price of rent, let's just say it is, let's just put it at $1,000, right? Now say the price of rent gets cut in half, right? Or it goes down by 75%, right? Um, when that happens, this whole condition of um, just changing one price and holding everything else constant sort of starts to break down, because um, rent is such a big part of your budget that if your rent was cut in half, or if your rent went down 75%, that you'd have so much additional budget that it'd be hard to really hold your income constant, your nominal income. Okay. Does that make sense? Because when we have your budget up here, remember, this is your income in nominal terms. So I'm going to change this to nominal income. So I'm just saying that the idea of the experiment of changing one thing and holding other things constant becomes a little bit more difficult when you're talking about a good that makes up a big part of your budget. So just because, like I said, if like most people in Southern California, they spend so much on rent or mortgage that if you cut it in half, they suddenly have a lot more money available than to spend on other things than they had before. So in the case of Giffen goods, if it was that a Giffen good made up a large percentage of your purchases, and then the price of the Giffen good changed, you would have a similar sort of situation where suddenly the idea of holding everything else constant and changing just the price of the Giffen good would be strained too. You'd have this kind of impact where it would have a big influence on your budget. So what economists have done is they decided, and this may or may not make sense. You have to draw a couple of connections here. But so we have nominal income, and then also real income, or what sometimes we call purchasing power, right, is our concept. What I can actually buy with my nominal income. And you might have heard normally in macro, we talk about this in terms of standard of living. Does that make sense, Russell? Are you familiar with these concepts?
Yeah.
Standard of living, right? And so your standard of living is this idea of what are the bundle of goods that I can purchase and actually supply me with food, clothing, and shelter, and those types of things. So normally in macro, we would represent those as real GDP per person, or that's the normal measure of standard of living in a country, is like the average real GDP per person. Well, here we're going to draw this parallel and say, well, really, what your real income is in a microeconomics context is going to be your level of utility, right? And this is probably conceptually the most sort of like difficult part of this, is to understand that now we're talking about real income instead of nominal income, and we're associating your real income with your level of utility, because your level of utility does measure your standard of living almost by definition. I don't know, does that make sense, Russell?
Mm-hmm.
Okay, so we can sort of like reformulate this question. And so the question is saying, how much X does the consumer purchase at new prices, holding, and I'm going to put in brackets, real income and utility constant at the level of utility associated with the original prices. Okay, so we're mixing things up here, and what we'll see is this enables us to do what we call a decomposition, and I'm gonna go ahead and grab this stuff. Okay. Okay. Maybe I can. Okay, my dogs are going crazy. Hold on just a minute. Okay. Okay, so this is the income and substitution effect decomposition that, again, it's gone through in detail in the lectures, and I'm just teasing this out here in more detail so we understand what we're actually doing in this problem. So how do we go ahead and construct this decomposition? Well, we're going to do something that's really close to what we've been doing so far with finding the consumer's optimal consumption bundle. But we're going to be finding the level of the two goods. And remember, we're labeling our goods X, S, and YS in this case. So to do this, find X, S, Y, S. Drag this out a little bit. Okay. So this is another simultaneous equation problem. And so we are going to have two simultaneous equations, and we're still going to have a tangency condition. And the tangency condition is going to be the same as it was before, which is the marginal rate of substitution is going to be equal to the new prices, right? Which is going to be the price of X and the price of Y after the price change. So the new price of tacos, the new prices of tequila in our case. So I'm going to put PX 1 divided by PY1. That's one of our equations. And then the other one is going to be a real income constant. So this is kind of like a budget, right? But it's not a budget. It's holding real income constant instead of nominal income constant. Does that make sense, Russell? Yeah. Oh, did I lose you? Okay. Okay, Greg, are you with me?
Yeah, I'm following.
Okay. Yeah. So the real income constant then is we're going to have utility is going to be equal to, and so generally, at least what we've been using so far is the Cobb-Douglas utility function, right? And so we're going to know the value of U0 star from solving the original consumer optimal or consumer's choice problem, getting their optimal consumption bundle. But now, remember, generally our utility is x raised to the alpha times y raised to the beta. And I'll put some brackets just to be a little bit clearer. Okay. But now, what we're going to do, sorry, is this is going to be the utility associated with our original optimal consumption bundle. That's how we'll get our U0 star, using our X0 and our Y0. And we also know that that's going to be equal to the same utility level using XS and YS. So remember our marginal rate of substitution up here is a function of XS and YS. Okay, so we have now these two equations, and we can use substitution and elimination like we did before. The only difference is that when we look at these two equations, it's gonna look a little different because now instead of having a linear budget constraint, we have this non-linear level of utility function here. And so things look a little bit different. But it turns out that it's pretty straightforward, and is we work through the problems, you all will see that. And okay, so that's the gist of what we're doing. Okay, so do you have any questions right now? Does anybody have any questions? No. Okay, so let's go back to the original problem and then begin to work on it. So the first thing that we have to do is so step one, and if you've been working through these problems on Ignithium for a particular problem set, is you have to find the original optimal consumption bundle. That's the first step. Okay, and I'll move this up. Okay, so let's see. Okay. Okay, so Devara, are you here this morning? So I'll say thanks to Greg and Russell. Devara? Okay, how about
Yes.
Jessica? Are you there, Devara?
Mm-hmm.
Okay, and Jessica?
Hi, I'm here.
Okay, so let's do step one. Okay, so go ahead and find U0. And do you know what I mean by U0? Because I can help you if you don't. And I'll call it U0 star.
Is it constant utility?
Well, it's not, yeah, so it would be the level of utility we're holding the consumer constant to. But I was just asking, like, if I ask you to find U0 star, do you need help with that? Are you good?
I need help with that.
Okay, well, okay, so I don't just bombard you with stuff. Can you tell me, like, okay, where are you, like, not connecting? Was that you, Devara?
No, that was me, Jessica. I'm sorry. Let me
Jessica.
just read the question again. I'm sorry.
Okay. What about you, Devara? Are you fine?
No, I need help as well.
Okay, and can you put a finer point on it, fleshed out? Do you need to read the question too?
Well, I just don't know how to find it.
Okay, well, can you find the consumer's optimal consumption bundle at the original prices? Do you know what that means? Or
Is it the price of the tacos and the tequila?
well, no, remember the optimal consumption bundle is how much tacos and tequila they're going to purchase at the original prices.
Oh.
That's our X0 star and Y0 star. I'm just abbreviating tequila. Okay. And do you remember how to find the amount of tacos and tequila the consumer is going to purchase?
Do we find the equilibrium?
Well, you could call the optimal consumption bundle an equilibrium bundle. That would be, I mean, we haven't really done that, but it wouldn't be wrong to do that. But I guess the question is more, the language is a little bit different here, because we're talking about optimal consumption bundles, and it is an equilibrium concept. It looks similar, but it's not the way we normally talk about it. Okay, I'm gonna dump that and we'll just focus here on this. So I don't know if you remember any of this. So who am I talking to? Is Jessica? Are you doing okay? Or
I'm looking over my notes to try to figure out.
Okay, so you should remember here we have again, a tangency condition.
Yeah, that's what I was looking at and
So
trying
this
to
is the
figure out.
alpha y over beta, and I'll write it this alpha y over beta x is equal to px over py. And this is the first part of this alpha y over beta x. This is our marginal rate of substitution for a Cobb Douglas. And then the second equation is the budget equation, which is just our income or our budget is equal to P of X times X plus P of Y times Y. And normally when I do this on the board, because it's easier to do subscripts and superscripts and things like that, I would normally, point out that we're trying to find prices at the original level. So I call this PX0 and this PY0. So later on, when we're dealing with the new prices, we're not confused of which prices we're dealing with. And then the result of these the two values of X and Y that solve both of these equations at the same time are our PX0 star and our PY0 star. Does that help? Are you sort of on board now? Okay, so I'll let you guys work on this for about 5 minutes, but just before I let you go, do you need any help translating these two equations based on the information we have, or are you good?
I think I'm okay. I think I can figure it out.
Okay, and that was Jessica?
Yes.
And Devara, what about you?
I'm gonna try it out first and see if I can get it.
Yeah, but do you know how, like, what the next step is? You just have to substitute these
Plug it in.
values in.
Okay.
What's that? If you
just plug the numbers in.
Yeah, and that'll give you two equations, and then you have to, like we did for supply and demand, it's a simultaneous equation systems. So you have to, write one in terms of the other variable that you're solving for, push it into the other equation, have one equation in one variable, solve that, and then substitute back in.
Okay.
So it's like supply and demand at that point, but you got to do the substitutions of the values of prices and stuff first to get the equations in a form you can work with. Okay. See you all in just a minute. Are you there?
I'm still working on it.
Okay, can you tell me where you're at or where you're stuck? Did you go ahead and substitute these in?
Yeah, so I substituted it, and I think, is it 7/2 for?
Well, I don't know because I haven't worked on it, but you should have an equation like that. Is that Devara or Jessica? Which one am I talking to right now?
Devara.
Okay, Devara, did you do this? So we say our alpha is 23/100, so it's 0.23 times y divided by, and so what's beta then? I'm getting silence on your end.
Is it 0.77?
Yeah. So that's 0.77x, right? And I'll just put brackets around it, right? Is equal to, and our px0 is 7, right? Over 2. Is that what you have?
Yeah.
So that's our first equation. And since I can see this right now, I'm just going to go ahead. You don't have to do this, but I'll just simplify it just so you know the fewer fractions we have there. So 7 over 2 is 3.5. And what about you, Jessica? Do you agree? Is that what you did for the first?
Yes. Yeah.
Okay. Okay. So what about the second part? What should it be, Jessica?
Is it 181 equals 7x plus 2y?
Yeah.
Okay.
Do you agree? Well, I mean, yeah, I mean, it's not supposed to be super tricky because on the other questions, you would have done this before too anyway. And by the way, I know that you all were probably studying for the exam and stuff like that, but our homework assignment's going to be due. I'm thinking probably I'll have it due like Tuesday of next week. So we're finishing it up because, like I said, you know, even though we took like a little bit of a pause so you guys could have some time to study for the exam that we just had, we're moving on to like the next stuff. So you can't, you know, shove it in the background for too long. But anyway, yeah. And do you agree on this, Devara?
Yeah, I have the same thing.
Right. Okay. So now you all should be able to solve for our x 0 star and our y 0 star, which is the consumer's, you know, optimal consumption bundle here, right? So is this where you got stuck, or you just haven't gotten there quite yet?
That's as far as I got.
Okay. Do you know what to do next? That was Jessica, right?
Yeah, no, sorry, I was thinking. No.
Okay. Well, these are just 2 equations and 2 unknowns, right?
Yeah.
So
Oh, okay. I see what's happening here. Yeah, no, I know now. That's, yeah, I'm sorry.
yeah. So what I would do is I would take this first one and I would solve for y all by itself. Is that what you did, Devara?
Yeah.
And what did you get?
I'm still working on it. Sorry. give me a
Okay, that's okay. I'll give you guys another minute. It's fine.
Is it 11.7x?
I'll put it down and we'll see if we.
I got
What did you?
I got 11.72x.
Oh, you have 7.2x like that.
Yeah.
like that.
X.
Yeah, and so there's probably no real disagreement. You guys are just talking about rounding differences, right?
Yeah.
Yeah. So I mean, I'll tell you, I'll do my, so obviously if I was going to solve this, I'd multiply both sides of the tangency condition by 0.77x. And in my calculator, when I do that, if I put 0.77 times 3.5, then I get 0.23y is equal to 2.695x. And then I would divide the 2.695 by 0.23. Okay, 2.695 divided by 0.23. Yeah, and so yeah, so it's, I have, 11.717. So yeah, it's 11.72. I would be a little bit careful of just truncating it, or just rounding there, just because you want to be as accurate as possible. You'll get better results, the more decimal places you use. In no case on Ignithium will you ever need to go beyond the fourth digit. But if you're want to make sure that your answers are really close to what it shows on Ignithium, then like, why not? Right. And so Devara, Jessica, so now you guys know what to do with the last part, right?
Yes.
You just substitute that right there, and then you can solve for x. And what do you end up getting?
For X, I got 5.95.
Okay. And what did you get? That was, I think, Devara. What did you get, Jessica?
Sorry, I'm putting it to my calculator. I'm really slow.
Okay.
Yeah, I got 5.95.
That's what I have. Okay. And then for y, you can then just go ahead and, right, once you have x, let me do this in a little bit different color. Once I have the x value here, right, I can just substitute it back there, and I'll get my y value, right? So I'm waiting for you all to tell me.
It's 69.7.
Yeah.
Yeah.
So
Yeah, 69.6852.
yeah. Cool. So now the last step, because I said we need our U0 star. is, do you all know how to find that? The consumer's level of utility now. Well, utility, right, is generally just x, because this is our Cobb-Douglas utility function, x raised to the alpha times y raised to the beta power, right? And that's x to the 0.23 and y to the 0.77. And I'll just put some brackets around here. So all we have to do is substitute in our values. Of x0 there and y0 there. And actually, maybe it'll be a little bit easier to see this. And if I just move this down here. Okay.
I got 39.56.
And that was Devara?
Jessica.
Jessica. Okay, what did you get, Devara?
Give me 1 second. Yeah, 39.56.
Yeah, okay. So I'm, I agree with you all. So, and if as you go through this assignment on Ignithium, because the problems are related to one another, you can actually check your work as you go along. It'll tell you as you solve the problems. I'm trying to move something around here. There we go. Okay. So, but that's just step one, right? So this problem, and that's why it's kind of nice that it's solved in sequence as you go through the assignment, because there are obviously a lot of steps here, right? So the next step is find XS and YS, right? So I'm going to go ahead and copy this. And remember, for XS and YS, right, now we have a different set of simultaneous equations. So we have to do the same thing that we did before. And we're going to have a very similar tangency condition, but now instead of a budget condition, we're going to have this real income constant condition. Okay, so I'll do Okay, so this gives us a little bit more room. So now we have our new tangency condition, and we have our real income constant condition. Okay, and I'll help you out a little bit again. So now this is going to be alpha y, but it's going to be alpha ys, right? Because it's a different point that we're looking for. So I'm putting a little subscript s over beta xs is equal, remember, to the new prices. So I'm going to put px1 over py1. So again, you got to translate this based on the information that we have. And now we have u0 star is equal to xs raised to the alpha, again, a different point, times ys raised to the beta. Okay, and then we've got to translate that. So do you all need help with this, or you I'll stick with you guys since we've been working on this, Devara and Jessica. Are you okay?
Could I see the question again?
Yeah. Well, what are you looking for? You looking for the prices? Because I can tell you, remember, the price of tacos drops to 6, and the price of tequila stays the same. So.
Okay, I think I got it.
So basically,
Okay.
for step 2, you do the same thing in step 1, but with the new prices, correct?
Yes.
Okay, thank you.
For the tangency condition, Michael. So, but the real income constant condition is totally different.
Okay.
Okay. So you want to help Jessica fill this in, or?
Yeah, for the tangency, is it 0.23y over 0.77x?
Yeah, and
XS
so I'm
equals 3.
Yeah, and I'm just gonna, yes, everything you said sounds good to me. Do you agree, Devara?
Yeah.
I'm just gonna write it like that to be clear. And then we have 6 over 2, which, as you said, is just 3. So that's one of our equations. Now, what about this one down here? I'll help, right? Do you see how step 1 and step 2 are connected now?
Yeah.
So do you want to handle this one, Devara? Jessica did the other one.
I don't know.
Well, you see how U0 star, the real income constant?
Oh, it's just equal?
Yeah,
Okay.
right?
Uh-huh.
So we're using that value. So it's going to be what?
39.56.
Is equal to dun, dun, dun.
Is it just x to the power of 0.323?
Yeah, exactly. So xs raised to the 0.23 power times ys raised to the 0.77 power. And again, I'll just try to be a little bit clearer by adding some brackets. Okay. So now we have the same sort of thing as we had before, right? Which is, we have a system of simultaneous equations. This one looks different because the second one is nonlinear. Do you see what I mean, Jessica?
Yes.
But we can solve it the same way, right? I
Yeah.
just get ys is equal to
I got 10.04 XS.
so you have 10. And what about you, Devar? Did you get the same thing in your calculator?
Yeah.
Okay. And then this is the part that probably seems trickier, but you'll see that it actually works out very nicely in terms of the math. So I'll help you guys with this part really quickly. And then hopefully that you'll see. So once I do this part, so I'm just going to write 39.56 is equal, and I'm gonna use the excess and keep it the same. 0.23, and then I'll just leave that. And then over here, I'll put in exactly what we had before, and I'm going to write it with an extra set of parentheses, 10.04 XS raised to the 0.77 power. Do you agree, Jessica?
Yes.
Okay. Now, you could go ahead and like kind of brute force this through your calculator, but, oh, I messed up here, 39. But okay, if you remember your exponent rules, then exponents distribute over the products. So you can write this as does that make sense to you, Devara, what I've just written?
Mm-hmm.
And then, right, these first two terms, if you have like x squared times x cubed, right, you just add the exponents. So we're almost done, right? Because XS raised to the 0.23 times XS raised to 0.77, by design, alpha plus beta, we know because it's Cobb Douglas is equal to 1, right? So that's just going to reduce to XS by itself. and we're going to have 39.56 divided by 10.04 raised to 0.77 power, which I think is pretty easy. Do you guys want to put it in your calculator and tell me what you get?
I I got 6.7.
Okay, you have 6.7. I'll just assume that that's
I got the
right.
same.
Okay, so you got 6.7.
Yeah.
And now, obviously, you can find YS also, because let me point out, right? You still have that original equation relating excess to YS here, right? So if we wanted to find it, we're totally fine. But so our question, I think we answered it then. It says, how many tacos will be consumed by your professor at the new prices, assuming utility is held constant? That's our XS bundle, right? And I'll just put it up here. This is from Ignithium. Do you all see the answer hint that I pasted? Jessica?
Yeah, I see that.
Deborah. Okay, so I'm clapping for you two.
Thank you.
So it's a little bit involved, right? But you walked all the way through question 19. And again, if you go through the details of the problem, you'll see that basically you're building up to solve these last two problems as you work through the assignment. So these steps, if you pay attention how each one of the prompts relates to the next one, in most cases, and especially on the exam, you're not going to have different prices and different incomes pushing all the way through. Most of them will be related. So, it's not a tremendous amount of work as you go through the assignment. It's all pushing you towards this, and it helps you check your work as you go along. Okay. Do you have any questions about this stuff? No. Okay. Going once, going twice. Anybody? Michael left or anybody else? Okay. Well, so I'm going to go ahead and transition here. So give me just a minute. And okay. So I want to show you all something which we've talked about. And let's see. You were talking to us earlier, Michael left. So let me talk to you since you're handy. Are you there?
Yeah.
So Michael, this is a page, and you guys could see this. This is from the University of Washington. It's linked to University of Hawaii. But if you just type in Google Cobb Douglas production utility functions, three-dimensional. Remember, the reason why I'm showing you this, and really the one that we want to pay attention to is the constant returns to scale case, okay? And here, notice that the parameters of this utility function or production function, that they're using A at the front here, and it's scaled to 1. So that's fine with us. A normally represents technology if we're talking about a Cobb-Douglas production function. In the context of utility, it doesn't really have an application, so we always assume it's 1, but that's fine. And then we have, we have X to Y, but this is, X to the alpha, and then their second dimension, they're just calling X sub 2 to the beta. So do you see that this is the exact same utility function that we've been working with, Michael? Yeah. And then notice this first box, right? We have, because the point here is this utility function is a three-dimensional surface, and we end up dealing with these indifference curves. You could call them in the context of production functions, we call them isoquants, and iso means the same quantity. An indifference curve means the same level of utility, so we could call these iso-utility curves if we wanted to also. But the point here is to demonstrate that when we have the utility curves, or indifference curves, excuse me, when we have the difference curves, we're actually taking a projection of this three-dimensional surface down into the two-dimensional plane that has our two goods on it, like tacos and tequila. So here, our X1 would be tacos and our X2 would be tequila. And you see how if we look at different points in the plane, a particular consumption bundle translates to a level of utility up on this utility function. So Michael, how would you describe the three-dimensional utility function? What does it kind of look like to you?
Yeah, I don't remember the name of the exact shape. I guess
Well,
you could
yeah,
say,
but yeah, go ahead.
I guess you could say it's kind of like a parabola that's been like kind of extended out into 3 dimensions.
Okay,
maybe.
if you were gonna use a non mathematical shape to describe it, what shapes come to mind?
I don't know, like a surface that's been bent or something.
Yeah, and do you see any of those in the natural environment around you?
But you mean like a mountain or something?
Yeah, like a mountain or a mound, right? That's what it looks like. It's like a mountain. And notice, so can you think of any differences here between, well, okay, so first of all, let's name this mountain. If you were going to give the utility function a name, if it was your mountain to name, what would be a good name for this mountain?
Mountain utility.
Okay. Does anybody else want to try a different name for our mountain? I mean, Mount Utility would be fine, because notice how I put Mount, right? Like Mount Baldy. Mount Utility. What's another good name? Anybody
So
wanna...
basically, the important part here is basically the peak of the mountain, would you say?
Well, it's funny because it turns out, and I won't go into details here. Obviously, we're just getting a subset, like a piece of the mountain, like a slice of the mountain is being illustrated for us, right? But it turns out that if we're to call it Mount Cobb-Douglas, because it's a Cobb-Douglas utility function, right? The Cobb-Douglas utility function mountain has no peak. It extends off into infinity, continually increasing as you get more and more tacos and tequila. So
that
it's hard
makes
to,
sense.
yeah, it's hard to see here, but it just turns out that that's the case. Okay, let's see. I have to ask
So
somebody else.
basically, you're just trying to like basically find the highest like point given like a budget, right?
Yeah, absolutely. And so Jeff Soria, you here this morning? Jeff Soria? Maybe not. How about Kenley? Kenley Wren.
Yes.
Hey Kenley, how's it going?
Good, thank you. Hi, Professor.
Hi. So are you following this illustration of Mount Utility as it was named by Michael?
Yes, well, somewhere in the middle.
Okay. Well, what's the kind of the challenge for you as you look at these pictures?
I wanna, not entirely sure what the red stands for. Otherwise, I do understand.
Okay, that's totally fine. So let's just focus on this first one. So if you were going to name this mountain a name, what would you call it? Mount what? We call it Mount Whitney. We call it Mount Cobb Douglas. We got those already. But what would be a good name for you?
You can try Mount Fiji. Fuji.
Oh, but why Fiji? See, I want you to relate it to the idea of utility. What's another name
I
for
see.
utility?
So Professor,
Yeah.
so do the indifference curves kind of basically paint like a topographic map?
Yeah. Exactly.
Interesting.
Yeah. We call it a contour map.
Right, yeah, that's
Right. So, but let's go back to Kenley. What's another name for utility?
Production?
No, it's utility. When you say your utility, remember we said one of the names that they actually used to use a while ago was Felicity.
So
Do you know what Felicity means?
Yeah.
What does it mean? Google it.
Is a place, amenity, or piece of equipment that's used for a particular purpose.
Really? If you Google Felicity, what does it tell you? What's the
Pretty
definition?
much a similar thing.
Oh, okay. I'm Googling Felicity here because so Felicity definition. I just on dictionary.com, you know what it tells me?
Mm-hmm.
Well, I mean, what about you? You must Google it too, right?
Mm-hmm.
Can you see my screen still? With Felicity up?
The definition.
Yeah.
Piece of
Can you see
equipment.
that?
Yeah.
Can you see my I have dictionary.
Sorry, my bad. My apology. Yeah, I was thinking of different words.
Yeah. So I mean, can you see my dictionary right now?
Yeah, now I see it. Sorry, I was looking at it I was thinking it's a complete different thing.
Yeah, I know. That's why I wanted to press you on that issue. So what is Felicity?
Mm-hmm.
What is it? Are you gonna read the definition?
Yeah, of course. Felicity is intense happiness or the ability to find appropriate expression for one's thought.
Yeah, it's really, the first definition is the preferred definition. So another name for utility is what? If it's Felicity, it's happiness. right?
Mount Felicity.
Yeah, we could call it Mount Happiness, right? Because utility measures the amount of happiness the consumer gets from consuming the bundle of goods that they're going to consume. It's does anybody else want to come up with another name? Mount what? How about you, Michael, Barbie?
Maybe like Mount Joy or Ecstasy.
Yeah, Mount Joy. I like where you're going. Mount Ecstasy, Mount Felicity, Mount Happiness, Mount Utility. Anybody else have another one? Michael Quintana, do you want to, or Miles? Gaelic? Nardine? Noah?
Yes, sir.
Do you want to name the mountain?
I like your guys' names.
Yeah. Well, you know, the how does this fit you? How about this? How about Mount Pleasure?
There you go.
Yeah. Okay. Now I'll go back to Michael left, right? What do you notice about Mount Pleasure or Mount Happiness that's different from a regular mountain? Do you notice anything, Michael?
Oh, you already said that the peak is basically infinite.
Well, okay, that's one part, and that's just because of the particular function that we chose. But yeah, can you think of anything else? What about you, Joshua Short? Can you notice anything?
Nothing for me, no.
Okay. How about this, Michael? The mountain is hollow. Right? There's nothing on the interior. It's just a surface. It's kind of like a tent. Right?
I mean, sure. I mean, you can probably integrate it, but yeah, sure, it's a surface.
Well, okay, yeah, you can compute the volume of a balloon. I mean, that's what integration is, right? It's about computing volume. But for our purposes, it's important to note that we're only talking about points on the surface of the mountain. There is no interior in any sense. There's no like mass to it, right?
Yeah,
so
it's just a function, kind of like a parabola. It's basically just almost one dimensional, even though it's on a two-dimensional
it's in
plane.
three-dimensional. Yeah. So
this is kind of like the same thing where it's basically a two-dimensional plane, but it's kind of curved on three-dimensional space.
Yeah, right. Like a piece of paper that's folded, right? So I guess the main point, the reason why I want is because also I think it's kind of an interesting, funny little thing that the mountain of happiness or the mountain of pleasure is hollow. But the other point is that yeah, when we take any consumption bundle in this XY plane or this X1, X2 plane, we're going to be scoring it with a level of utility that's going to be projected up onto the surface of that mountain. And then what we can do is I think it was, who was it who said the red part confused them? Was it Kenley?
Yeah, that was me.
Yeah, see, Kenley, what we're doing is we're taking slices of this mountain, okay, which is a particular height level or a particular altitude. And so if you look at this red part here, this is actually a horizontal slice. So you can see that there are a bunch of points on the mountain that all have the exact same height. And then what we're doing is we're taking that, it's basically a curve here, right? Going, because this mountain is rounded.
Mhm.
And then we're showing in this third picture, we're showing these indifference curves, or these isoquants, which are these slices of different heights of the mountain. And we're showing you without, you know, graphing all of the points in the mountain, but just a selection of them. Then we can get these general shapes of what these indifference curves or these different altitudes look like. This is what Michael and I were talking about when we said it's a contour map. So yeah, so now that we have this contour map, we can just let all of these different indifference curves be represented only in the two-dimensional x1, x2, or xy plane. We don't need the third dimension anymore for height, because we can just label these as different levels of utility. So the main point is that there are a bunch of different consumption bundles that all generate the same level of utility, and they can be represented as a single line or a single curve in the XY plane. So we can take this three-dimensional graph and we can collapse it into a two-dimensional set of curves. And that's what we've been doing. So that's why I wanted to show you this. I'm sure this probably makes sense to you, Michael. Right, Michael, you understand what I'm talking about.
Yeah, that's what a topographic map is. Because you know, you have like three-dimensional mountains, so you represented on a piece of paper using contour lines.
Yeah, exactly. And so what about you, Kenley? Or does it make sense to you?
Yeah, it does. Naturally get it now.
Yeah. And there's one other thing, though we don't do it, is you could slice the mountain a different way. And if you do that, so instead of taking horizontal slices, we can cut this function along one of the axes. And what it shows you is, so for example, notice this red plane here, cutting it vertically at a particular level of x2. This is, again, x1 for us would be tacos, and x2 would be tequila, right? It's showing me for a certain amount of tequila. Now, if I have like 5 shots of tequila, then I can see how the addition of extra amounts of tacos only, right, is going to increase my satisfaction, which again is another name for happiness, felicity, joy, my satisfaction. So this is the marginal utility of x1, which is how much additional utility x1 gives me holding x2 constant. And notice that my utility goes up as I get more and more tacos, but by a decreasing amount. That's what we mean by diminishing marginal utility. Do you follow Michael and Kenley?
Yeah.
Okay.
Yes.
And we could obviously do that. It's not done here on a constant amount of x1, letting x2 vary, but it would look the same way if we just cut it a different way. And I don't think this last part is particularly instructive, but you know, you can see how like holding a certain combination of the two goods constant and like moving along array, how your utility would increase. So anyway, this constant returns to scale is what we're working with throughout this class, and we won't really be dealing in any great detail with either increasing or decreasing returns to scale. Sometimes they talk about it in macro. Okay, so I'm gonna stop the share. Okay, so I think that's almost enough for today, and we're just about out of time. So I'm gonna go ahead and stop.